Hello. Today we're going to discuss Chapter 6, Section 2. Section 2 has two parts. The first part is about the volume of rotation and the disk method, and the second part is about the volume of rotation and the washer method. So today we're going to discuss the volume of rotation with the disk method, and for this video we'll then discuss case 1. So here's a hint. We are given the region R, and the region R is described by this data. You have the region R is bounded by above by y equals square root of x, and to the left by x equals 0, to the right by x equals 1, and below by the x-axis. So when you graph the square root of y equals square root of x, this is the curve you see, and x equals to 0, it's right here, and x equals 1 is going to be at this vertical line, and the x-axis is this x-axis. So all four combined give us this region R. And what we're going to do is rotate the region R with respect to the x-axis. Those curve arrows basically tells us you're going to take this region, you're going to rotate this 360 degrees with respect to the x-axis. So by doing that, you're going to the rotation we create this type of object of solid. Okay, and think of like you have a football, you cut it out, you get half of it. So and then they ask you to find the volume of the half of football. So that's what we're doing here. Now, let's go to the concept. Case 1. So for case 1, the region, they give us the region R, which is described by, it's described as such. Region R is bounded above by the curve y equals f of x. The PDF kind of did this, split this like that. And then to the left by x equals a, the line, vertical line x equals a, to the right by another vertical line x equals b, and below by the horizontal line y equals k. And then they tell us that the rotation is with respect to the line y equals k. So this is the line y equals k. So we put those curve arrows to show the rotation. So that's where we're going to revolve this region 360 degrees with respect to this this line, horizontal line y equals k. As you can see, the region is bounded in terms of the x-axis. It starts at x equals a and ends at x equals b. So the question is to find the volume of rotation. Okay, so when you revolve it, you may get something like this. Again, the PDF kind of split everything. So you're going to, if you put this together, you're going to get this kind of object. So the point is, what's the volume of this object? Okay. So to find it, what we're going to do is go to some point between the left hand and the right hand of this object. So at some point between, we're going to call that point X. So we're going to slice, vertical slice. Okay, so we're going to slice this object at the point X. It's a vertical, so you slice it vertically at the point X. So when you do that, I mean you cut it there. So when you do that, and then you look at your cross section. So this is what we call the cross section region. So when you look at the cross section, you're looking at the cross section. It's like the right, the side view here. Okay. So you're looking at the side view. You're going to see a circle or a disc. Okay. So this disc is what I copied here. Okay, which was split by PDF. But so this is the disc, and when you see the center of the disc is at the line of rotation. So y equals k. So the center is y equals k, as I wrote here. But the top part of the disk is where the curve is y equals f of x. So at the top point is y equals f of x. So when they ask us to find the radius of this disk, so so the center is y equals k, and the top point of this region, this radius is at y equals f of x. The radius is just the distance between these 2 points. To find the distance between those 2 points, think of this. If you have the vertical line, like we call it y-axis, so you have a 2 points, you have 0.5 and then 0.3. They ask you to find the distance between the 3 and 5. Usually what we do is we take 5 minus 3. So the bigger number minus smaller number. So the distance between 3 and 5 or 5 and 3 is a 2. So let's use the same thinking and then use it in our case. So the top point of the disk is f of x, and the center is k. So the radius is the distance between f of x and k. As we did here, we're going to take f of x minus k, and we're going to call that the radius of this disk. Now, in two-dimensional, the cross-section, so when you look at the cross-section here, you will basically see this line segment. Okay, it's a line segment. We call it the cross-section line. So this is the two-dimensional. That's the three-dimensional. This is two-dimensional. We're talking about x and y plane. So this is the cross-section line. In two-dimensional, the cross-section line goes from it goes through the region. Okay, so you pick any point between A and B, you call it X, and then you draw your cross-section line segment, which is this. So the cross-section line here is vertical. Okay, and the cross-section line in case one, it's always the cross-section line for the disk method is always perpendicular to the line of rotation. Perpendicular means the two lines do form a 90-degree angle. So when you see here, you can see that to find the radius, you take the top point here is y equals f of x, and the point below is y equals k. So the radius is f of x minus k. Okay, so step one is to graph the region, and then mark everything that needs to be done there, like the line of rotation. You put those curved arrows, and then you show the cross-section line, you show the region, and then you show you find the radius, which is f of x minus k. And then you go to step two. Now it's just some kind of routine. So you write down your radius, which is you name it r of x, radius as a function of x, because you have f of x here. So r of x equals f of x minus k. And then the next step, step 3, you go and find the area of this region. Okay, I mean the area of this disk, which is the area of the circle. So the area of a circle in general is always pi times radius squared. Our radius is f of x minus k, so we're going to replace r of x by f of x minus k. We get the area. Now, to find the volume of rotation, what you do is you integrate the area of the disk. Okay. So you're going to integrate a of x from a to b. A to b, why? Because you can see here, when you look at the region is bounded in terms of x, is bounded by x equals a and x equals b. So that gives us the limit of integration in terms of integrals. Now, one thing I want to let you know is when you draw your line of the cross-section line, if you extend it, it's going to hit the x-axis. It's going to intersect the x-axis here at that point called x. So this point x tells you that everything that you do here must be in terms of x. Even when you set up your integral, it must be in terms of x. So here again, when you look at the integral, when we're integrating a of x, we doing it with respect to x variable. So that brings us the lower limit a and then the upper limit b. And then we go replace a of x by f of x minus k. So we get the volume of rotation. Okay, so that's the concept. So now let's do an example. It says to find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. So they give us the region. The region is described by these four data. So let's graph. And the rotation is about the line y equals 1. So first let's graph the region. So that's step 1. So we know this is to graph y equals square root of x. This is the curve. And then y equals 1 is this line, horizontal line. And then x equals 1 goes just up to this point. And then x equals 4 becomes this vertical line. So all four data create the region called R. The rotation is about the line y equals 1. So we're going to take this region, we're going to revolve it with respect to the line y equals 1. Now, so our job here is, well, after you graph this, you mark the rotation. You will then draw since the rotation is, the line of rotation is horizontal, you know that the cross-section line will be vertical because the two must be perpendicular. So you draw your cross-section line segment, okay, and then you look at the top. The top point is the curve itself, y equals square root of x. The bottom point of the line segment is y equals 1. So the radius is this distance between the 2 points. So the radius is going to be r of x minus 1. Okay. So you get square root of x minus 1. So you get the square root of x minus 1. So you name it r of x. After you get the radius, then you just follow the routines. You have a step 2. So write down the radius, r of x equals square root of x minus 1. Step 3, find the area of the disk. You call it a of x. So area in general of a disk is pi times the radius square. Since r of x is the square root of x minus 1, you can just plug in r of x. You can plug in square root of x minus 1 for r of x. And when you get to your area, we know by definition to find the volume of rotation, you'll have to integrate the area of the disk. So the limit of integration, when you look at the region is between x equals 1 and then x equals 4. So then your lower limit is 1, your upper limit is 4, and you're going to integrate a of x, which is pi times quantity square root of x minus 1 all square dx. Now when you go back to do such an integral from calculus 1, you'll have to expand this expression first. You can FOIL it. After you FOIL it, you get the square root of x all squared minus 2 times the square root of x and then plus 1 squared. Now, square root of x squared give you x. So minus 2 square root of x and then plus 1. And but we cannot still integrate because we have the square root. So we'll have to change the square root of x as x raised to a half. So then we are ready to integrate. Pi is a constant. You can always move it outside of the integral sign. So when you integrate x, you're going to have x squared over 2 minus 2 times, you integrate x raised to 1 half, it's going to give you x raised to 1 half plus 1 over a half plus 1. Plus, when you integrate 1, you get x. When you're done integrating, you're going to evaluate this expression at 1 and 4. So first you plug in 4 for x into the expression, and then minus, and then you plug in 1 for x into the expression. And then you use your calculator to finally get the volume to be 7 pi over 6. So this video ends with case 1. With the next video, we're going to start with case 2. Thank you very much for listening.